All right. I can't
Oh,
figure.
you're talking about down at the bottom where it says share screen, record reactions, and all that?
No, up here at the top, if you can see my cursor, when I move up and I'm interacting with the Zoom application, I'm curious whether you see my menu, my cursor moving menus and stuff like that right now.
No, no.
All right. I should just dial in myself with a separate computer and watch that. All right. Because I know that it hides some things of the user interface and the others that it doesn't.
Yeah, I just see your desktop. That's it. I don't see anything with Zoom. I mean, I don't see anything. It's
Sure. All right. So default arguments. I believe I've talked about this a little bit, but a default argument is an argument that is passed automatically to the parameter if the argument is missing one on the function call. And I absolutely know that I've talked about this because I remember discussing that if you're going to have a default argument, it needs to be set in the prototype if you have a prototype and not in the function itself. You can only set it in one place or the other, but if you have a prototype and you want a default argument, that's the place to do it. And so it's just to give the code the ability to, you could call it with as many or as few parameters as you wanted. Where's my recent projects? So yeah, we had, I believe, in the last lecture, a method called, or a function called add them. And in it, we created all of these parameters, but they all had default arguments. So that if we wanted to, we could call them with one argument, or with two arguments, or with four arguments. I wonder why I commented that one out. There's nothing wrong with calling it with three, right? That would work. So just gives the ability to customize the behavior of it if you want to, so that you can be as specific or as general as possible. I could even call add them with nothing, but it's going to return, 0 because all the default values are getting stuff with 0 there. Their example is a little bit silly because they have a function called even or odd, and they're saying that if you feel like it, you could pass in nothing. So when I'm ready to call even or odd, right, if even or odd, I don't even need to pass in anything. So what am I checking the evenness of, right?
Yeah.
I don't know. But sure, they set it up that way so that if you did not pass in anything, it would come back and say that it was even, I assume, because I know that what their check is going to do is to modulus that number by 2 and then return whether it's non-zero or not. So display the number of stars, where we have a number of rows and we have a number of columns. And just like I keep saying this every time I talk about prototypes, I think it's needless to leave off the variable name, the parameter name, because if I was looking at a prototype and I saw this, I don't know what these parameters that I can pass in are without actually going and finding some documentation or finding the source code. But if it said void display stars, rows, comma, columns, then I would know. So this bit about leaving off the variable names, I don't know who decided that that was a good thing, but I would never leave off the parameter variables in my prototypes, except for the fact that the books show it that way, because it's useful information. Okay. So they've written a function on the next page that will use a nested for loop to print out asterisks of a certain number of rows and a certain number of columns. So when it zips into here, it's going to have an outer loop that steps through the number of rows and the inner loop that steps through the number of columns, printing out asterisks. I think we've probably written those almost exact same little chunk of code here. And so to print out a row of asterisks, go to the next line. It'll print out another row, go to the next line, and it does that until it has exceeded the number of rows. Since there are default values provided for it, you can call display stars without specifying how many rows and columns you want. Or you can say, I want 5 rows. Looks like they've got columns first and then rows, but whatever, you get the idea. Reading the comments here, it looks like columns is first and then rows. So here, I'm going to print something that's 5 columns wide, and I'm just going to accept the default number for the number of rows, which happens to be 1. And now I'm going to print out something that's 7 columns wide and 3 rows wide. And so I have the choice of doing, any of those combinations, leaving them all off, specifying one, or specifying both. Now, some
So
languages have,
even though they're declared up there in 10 and 1, you can override that.
exactly. We are overriding them, but if we don't override them, that's the values they get.
I see.
If we do override them, then they get the new values. Lecture R. So that's my prototype for it. And I forgot to give that one a data type. Come on. Chrome, I don't know what you're yelling about, and I wish you would stop. All right. So that's my prototype, and now I'm going to put an implementation of that function down here. That's what I kept trying to fix when the Chrome started yelling at me. And now we're just going to have our nested loop. So counting up the number of rows, and then inside it, the number of columns. I don't know why I used I. Usually I use like X and Y or R and C since they're rows. Each time, print out some little cute symbol. Once we are done with an entire row, we have gone through all the columns, we have printed out an entire row, we want to go to the next line. And that's that. So when we call it, we could call it and say that I want like that, and it'll print a 5x5 box. Or I could do that, and it'll print a 10x5 box. And notice as I was typing, the IntelliSense was telling me what the default values were. In there it says int rows equals 5, calls equals 5. That lets me know that I don't even have to provide them, and those values would be accepted. But I can override them with my own values.
So I know you've covered this, but I'm kind of struggling a little bit with we've got void draw box twice, and I know you went over this in the last.
Right. This one is called a prototype because it doesn't have a body. And the point of the prototype is so that before we knew anything about prototypes or anything like that, we always had to put our functions above main, or else it wouldn't be able to call them. Without that prototype, this code would not compile because it was not defined above main.
I see.
So when I try to run it, it's going to tell me sorry, Charlie, I don't know what these are. There were build errors. And then if I went and I found the error list, it would tell me too few arguments in function call. Well, I don't know how it knows that because it doesn't know what it needs. Identifier not found, identifier not found. You see, it doesn't know what drawbox is. And so one way to fix that would be to cut this and paste it and move it above main. But we really don't want our functionals to be positionally dependent upon each other like that. We might want to even be able to put their functions in their own separate CPP file. And so to let it go ahead and compile, even if this function hadn't been written yet, it'll now compile because the prototype tells it the name of the function, the name, the types of the arguments, any default values, and what it can return. And that's enough for the compiler to go, okay, yeah, I know what drawbox is, you know, I know the plan. And so it will compile. It won't build because that function is missing. I cut it.
Okay.
And I could go and I could add that function in to another CPP file, or I could just go ahead and paste it back in the bottom, which is what I'm going to do. But as long as it has access to the prototype that gives us the details of the function, then the compiler can go ahead and go and run, even if that function itself has not been defined yet with a body.
I see.
So a very common prototype paradigm is to put, you know, your prototypes in a header file, and then to put, you know, some functions in one CPP file and another file, and so on, to break your large project up. So one thing about default arguments is that once you start assigning default arguments, the rest of them have to have them, right? So it's okay to go, okay, I require that to have a value, but it's okay if the programmer skips giving that one a value and skipping that one a value. That's fine. You could write a function like that. But if you, once you start providing default arguments, the rest of them had better have them as well. And what do I mean by that? I'm going to go ahead and write another add method that takes I, J, K, and L, and it returns I plus J plus K plus L. I really wish this syntax worked, and it does not, of course. Anyways, if for some reason I decide that, well, J, if you don't want to pass in J, that's okay. I'm going to assign that it's 2. I'm going to decide that it's 2. Well, that's not going to work. It's not going to compile. And the reason why is, how could you skip providing a value for J and not provide values for these, right? Because if I'm going to call those things int X and I want to add 1, oh yeah, I'm going to skip J, aren't I? So I only have to give K and L. You know, it doesn't work like that, because it doesn't, it needs them to be in the order that they're declared in, right? So this won't work. That one's going to go there. Well, where's that 2 going to go? Is it going to skip that default one and go into there? No, it's just going to go straight. The first one goes into the first, the second one goes into the second, and the third one's going to go into the third, and we don't have a 4th value yet. So anyways, once you start specifying optional arguments, the rest of them in the same function also have to have default values before it'll not compile. I mean, before it will compile. Then and only then is it ready to compile.
See, I'm getting an error. Void function add should not return a value. The return I, J,
You're right.
K,
I could not figure out why I was getting an error. It's because it's not void. I wanted it to return an int, right? Because it's supposed to add those numbers and return them. There we go. That was my brain fart. I couldn't figure out why I was getting that. All right. So I hope that makes sense. It's illegal to provide some values and then on later parameters not provide them. Once you provide an optional, the rest of them have to have optional values as well. It doesn't mean they all have to, but the first time you do, all the ones after that have to have them as well. So it's okay to have the first one be a mandatory parameter and then the second and the third one be optional. but it's not okay for the first and the third one to be mandatory and the second one to be optional. When an argument is omitted from the function call, all arguments after it must also be omitted. You don't just start putting commas there in order to pass in blanks, right? I wouldn't do this. I wouldn't do int y is equal to add. I'm going to add the values 10, 20, and then nothing else. You just leave off the extra commas and then let it figure it out. Reference variables as parameters. When we pass data in, we're passing it in by copy. C++ does pass by copy. And I think I talked about this in the last lecture. And it's been a while since it's been a week since I recorded that lecture. So pass by copy means that if I do something like this, void change me, and I take a value in and I reset it, like to, 999. If I declare a variable like int abc is equal to 3, and then I call change me, and then I print out abc, is it going to print out 3, or is it going to print out 999? It looks like it would print out 999 in a way, right? Because we set this thing equal to 3, and then we call change me, it runs up here, x is now equal to 3, we change the value of x, we return, is ABC now equal to 999? No, ABC is still equal to 3, because this variable and this variable are not the same thing. This just gets a copy of this. It just gets a photocopy of it, and if it feels like changing the value of it, and that's fine. It still does not change the value of ABC. And it's kind of a good thing, because what if I just passed in a number here, right? Change me 6, and then we're changing the value of that argument to 999. Is that automatically, is 6 now equal to 999 in some weird universe? No. So it's doing pass by copy. It's passing in a variable by its value. And so pass by value, it gets the value 3, and then it can do anything it wants to with it. But any changes to it do not affect the original variable. So when I run this, it's still going to say that ABC is equal to 3, and it's not going to say that it's equal to 999.
What would you do to get x to be 999?
That's what we're going to talk about. There's 2 or 3 different ways to do it. One is you could just make it return the value. So you could say int change me 1, and then if you're going to change its value, x equals 999, then we just return it. And so down here, when we want to do that, change me 1 x, but you better store its return value. Like that. And I'm getting errors, and I don't see why. Oh, ABC, excuse me. Now that's the easiest. I mean, I'm not going to say that's the easiest, but you can always return a value and then catch that return value.
Okay.
So that's a way of doing it, but it doesn't really do what we were talking about, which is give this function the ability to actually change it. So we're going to write one called change me, or change ref. Int change ref, change by reference. And I have to declare this variable a little bit differently. I need to put an ampersand in front of the x. And I'm going to say x is equal to 999. So when I call change me, if I pass, oh, come on. There. If I could disable the touchpad of a laptop as long as there is a mouse plugged into it, I would. Alrighty. So I don't want to do that. Instead, I want to call the new version of it. Change me underscore ref, and I'm going to pass in ABC. Oh, that's because I just called it change me reference. So what is it doing? This ampersand means I don't get a copy of the data. I am the data that you passed in. So this variable and this variable are now the exact same thing. And so any changes to that also change ABC. And so when we do it, when we print it out, it now is going to print that ABC is equal to 1, 2, 3. And somewhere up there it did that, right? So ABC is equal to 999. That's passing by reference. So by default, parameters are passed by value, passed by copy. The parameter gets a copy of the argument. If you define the parameter as a reference using the ampersand symbol, this marks that the parameter is a reference to the original argument. It isn't, to all effects and purposes, is the original argument. And any changes to it will modify the original argument variable. So by default, parameters are passed by value, or they're passed by copy, period. The parameter gets a copy of the argument. So changing the value of the parameter variable does not modify the value of the original argument variable. That's not the only place where you can define a reference. If you wanted to, you could just do this. Int, or how about, we don't have string included up here. I'm going to include string now. And then down in main, I'm going to write a string. I'm going to call it me, and I'm going to say that I am Joe Bob. And then I'm going to say that myself, but I'm going to use that ampersand. String and myself is me. Now myself is not a copy of the me variable. Myself is the me variable. They both are the same data. They both point to the same area in memory. So if I do this, myself is equal to, I change my name a little bit. I am Joseph Bob. And then I print out me. It's, even though what we changed was the myself variable, the name, the value of me is going to have been changed. I mean, I could even blank that out entirely, right? So I'm changing me by changing myself, because both myself and me are pointing to the same memory, because myself is a reference to me. And so, yes, by changing myself to Joseph Bob, the me variable contents were also Joseph Bob.
So if you just said string myself equals me, that would not change me.
Exactly, because myself would be a brand new variable. Oh, come on.
Okay.
Myself is a brand new variable with a copy of the contents of me, but they're separate. And so me is blank because we did not give it a value. Okay, so why do you care? Why would you ever want to do what I just did here? Why would I ever want to create a reference to another variable like that? Well, there's no reason you would do that. I cannot think of a time when I ever thought, hey, I'm going to give a variable two different names. But this kind of circumstance, it is useful. If you need this function, the ability to do some math and to pass some results back, then the results can be passed back through their variables by their parameters. And so what's an example of that? What if we had some function that was going to multiply two numbers or double the value, triple the value of a number? No, it was going to invert the number, right? So if you passed in 3, it would pass in 1/3. But what if they pass in 0? Then it would crash because 1/0 is, an error. So let's write a function called invert. And it's going to take a value that we want to invert. And then it returns, the result. The result is equal to 1 over the value. And then we return the result. Now that's well and good, but if we call it and we try to invert 0, double D is equal to invert 0, it will crash. So what do we, tell you what, I don't like it doing it that way. Oh, one thing about, sorry to jump tracks. I'll go back to the point that I was just about to make in a minute. Let's take our value that we were going to do and assign it to be 0, and then let's invert it. So D, double D2 equals the inverted value of D. And this will crash because we're dividing by 0. Or if it doesn't crash, it's going to return some result that we really can't use. What would be nice is if this thing could return a value, either true or false, indicating that it succeeded. So to do that, we could call it safe invert. We could make it return a bool. And if the value that was passed in is 0, then we return false because it's not safe to do. So if value equals 0, return false. It's no good. No good. Can't invert 0. But now we need something that will store the result. So double ampersand result. So I better get rid of that one. So what is happening now is that if we want to call the invert function, we need a variable to hold the result. So like double D2, perfectly good variable to hold the result. And now we can try to invert it. If safe invert D D2, then we could print out a message saying the inverse is what? The inverse of D is D2. Else it failed because it returned a false. See out, could not calculate reverse or inverse. Could not evaluate. There we go. Okay, so we have a function that's returning that's calculating a value, storing the result in one of the parameters to pass back to the main code. Maybe instead of D2, we could have called it result or answer or something like that, because these variable names are kind of vague, right? So when we call safe insert, we're passing in the value that we want to invert, a 0. It's doing the inversion. It's doing the check first, though. Did you pass in a 0? Well, you bad boy, then I'm going to return a false to indicate that we couldn't do it. Otherwise, it's going to go ahead and go so, and it's going to divide 1 into the value and return that. So if we run it, I'm expecting to see it say, could not calculate the inverse, because we did set the input data equal to 0. I'm going to remove these braces because I like to be able to see a lot of stuff on the screen at the same time. Okay. And so up here, could not calculate the inverse. But if we change it to a non-zero value, like 2, the inverse of 2 is 1 over 2, which is 1/2. So now it should print. The inverse of D is 0.5. Ooh, is infinity. Well, that just blows my mind. I'm going to have to debug this, so I'm going to set a breakpoint on the code right here, meaning I'm going to click on the margin, and I'm going to debug. So let's run the debugger.
Where are we declaring value?
The value was passed in here. Oh, it's still 0. I thought I changed it. I swear I did.
You changed the if value equals 2.
Oh. Okay, talk about a brain malfunction. That is what I wanted to do, is I wanted to pass in a 2, right? This is the safety check. I should not have changed that at all. I have no idea why. You know, dang, that was dumb. All right, so we're passing in a 2 now. And so it should do 1 over 2, and we should get 0.5 on our way out. And so the inverse of D is 0.15. So why would you bother doing that? You do that when you have some kind of function that needs to return more than one value. In this case, we're returning 2 values. We're returning a true false to indicate whether it worked or not, and we are returning a result. So another example. So I want to be able to set the first name equals to John and the last name equal to Roberts. And so I want to be able to call make John with 2 strings and then print out those results. String S1, S2. Make John S1, comma S2. And then if I print them out, print out S1 followed by a space, followed by S2, then it should print John Roberts. However, we know it's not going to, because these variables are being passed in. They're being passed in by copy. So first and last get a copy of this data, and who cares if it changes it? It's only changing the copies. So to make this work, we would do that. Now what are you complaining about? I hope that error goes away when I compile, because that doesn't make any sense. Yes, it did. Okay. And so it was able to print John Roberts. So if you have a function that needs to pass back more than one return value, that is how you do it. There are other ways you could do it as well, but that is one way how you do it. You use reference parameters. Something similar to references is the idea of pointers. So just like we had me and myself being two separate things and we could change me by changing myself, let's have a string you and a string pointer called yourself. And you can change the value of you by modifying yourself. If we say that yourself contains the address of you, it contains a pointer to you. So this asterisk means that yourself is not a string, it's a pointer to a memory address that holds a string. What memory address does it hold? It holds the address of the you string. I'm going to cut that part off and put it down later. And so yourself equals ampersand you. The ampersand means address of in this particular case. Elsewhere, it meant reference. And I don't like the fact that they use the same symbol for two different purposes, to mean both pointer, to mean both address and reference. But in another version of C called C#, they changed it so that if you wanted to use a pointer, it was a different symbol than the reference symbol. So anyways, so now that he has got the address of that, if I gave you my address, you could drive by my house and spray paint it red. So now that this variable has the address of this variable, it can change it. So, but it has to do so by its pointer. And so now if we print out you, it's going to be George. What? Why am I typing that? There we go. So we created a pointer and we set that pointer equal to the address of another variable. And so then when we wrote to that memory, it changed the contents of that original variable. And so you now has this data written to it. A little bit more complex than using the reference was, right? When we had me and you, it was real easy to do. I declared this string and then I just created a copy of it like that, right? It's not that much worse. String she, string pointer to a string. Now normally, I'm not going to even get into that. Herself is equal to the address of she. And now we're ready to change her. Come on, finish typing. All right, there. So the contents of that address, we're going to store the word Sheila there. And so if we print out she is followed by that variable, it will say that she is Sheila. I hate those little phantom errors. They indicate that it's an error and then eventually they disappear. Anyways, okay. So that's an example of using a reference to point two things to the same memory. This myself variable is actually the same variable as me, and using a pointer to point two things to the same memory. Herself is not the same variable as she, but herself has got a pointer to the same memory that she is stored in, so that when we change it by its pointer, then we are changing the original. And again, when do you use that? Doing it like this is just kind of silly, but you can do it inside of functions. So when we did a make John here, we could write make void make Jack, and it's going to use pointers instead. Now I am going to do something that I was just about to mention and I didn't, which is that as a matter of habit, any time that I declare a pointer variable, I name the variable with a P as its first letter to indicate that it's a pointer. That way I know that it's not, a piece of data itself, it's a pointer to data. And so I could say that P first, and then P last. Let's see, who's named Jack in the world? Jack White of the White Stripes. There we go. What? There we go. So if I call make Jack and pass in some string A comma B, and I'm going to call make Jack, and I'm going to pass in the address of A and the address of B to that function so that it can change those values. And then I can see out A comma B equals A, followed by a space, followed by a B, followed by E and DL. And why not system pause here so I don't have to look at the rest of that. So this won't be the only time we see pointers. We'll be talking about pointers again, so it's okay if it doesn't totally sink in the first time you see what's going on here. But it did get changed to Jack White. The variable A was passed in by its address, just like I sent you my address so that you can go do something to my house. It doesn't matter that it's a photocopy of it. It's a photocopy of my address. You can still use a photocopy of my address to show up at my house and spray paint it red. So the A means turn this into an address and pass it in. And now that we have the address, we can use, this asterisk is called dereferencing. There should be a better term for it. But if you put an asterisk in front of a variable that's declared as a pointer, it means don't change that variable, change the memory that it's pointing to. So this isn't changing the value of P first, it's changing the memory that P first, the address that has stored in it. Because if I just did this, that'd be a syntax error. You can't change P first to a string. P first isn't a string. Why? It's a pointer to a string. It's a memory address of a string. But I can tell it, okay, go and change what you're pointing to. And so when we invoke make Jack and we pass in at the address of A and the address of B, it's able to fill those in and pass them back. So two ways of changing data that is passed to a function. One is to pass by reference. The other is to pass by pointer. Passing by reference, I think you might agree that it looks cleaner, that it's easier to understand. We're not having to deal with these little stars and naming things P's and stuff like that. Well, that's because this was invented long after this was invented, right? This is like the 1970 version of C supported this. And then C++ invented in 1985 supported that. They came up with a better version of it because improvement's a good thing to do. So if I was going to call make Bob, make John, I don't use those address indicators because it wants references, right? If I look here, it's saying, I just want two strings, but this ampersand means that it's okay. I'm going to treat them as references. So I'm going to have access to their contents. I can change them. And then if I print it out again, it'll print out John Roberts or whatever we said it was going to do. Right, so It called it each way. Now the drawback, perhaps, about passing by reference is I don't really have a clue that my data is about to get changed, right? And then this function wipes it out, right? That's going to replace whatever was stored in A with its new value. So some languages make it so that you have to pass in a special symbol here. You have to like type the word ref in to indicate that, oh, by the way, this is a reference variable and it is going to get changed, so that you, the programmer, know that when you call that function, there's a high likelihood that the contents of that variable is going to be replaced. So one more thing about reference variables is that was one of our examples. This inversion, when we were going to invert something. Now, how about change me? Change me by ref. Since it wants a variable to refer to, we can't pass in a constant. So wherever I was using change me, way down in the fullness of time, I couldn't do this. I can't do change me by ref and then pass 100 in. Why? Because it was supposed to be trying to change it to 999 or 123 or whatever its magic value is. It cannot rewrite the bits of 100 to make it equal to something else, right? And so if you declare a function, if you declare a parameter as being a reference parameter, then you have to pass in a legit variable into it. You can't pass in a constant like that, either an unnamed constant, a literal like that, or passing in, you know, const int can't touch this equal to 200, right? We can't pass that in either. Because this function is liable to change it, right? That's the entire point of change me, is to change the value of whatever was passed in equal to 999. And since can't touch this has been declared as a constant, can't change it. So that's a syntax error. We'd have to fix that. All right, I'm going to keep talking about references, even though we've already talked about them for quite a while. Are there times when you would want to pass by reference, even though you don't want to change the data? And the answer is yes. And why is that? Because when you call a function, you're copying the data into it. And these little pieces of data are simple, small pieces of data. They don't take any time to copy at all. But when we're working with classes, you could write a variable that has 2 kilobytes of data stored in that one variable. You know, a string could be just no bytes long, right? Or it could be 100,000 bytes long, right? If you stored an entire chapter of a book into a string, which you could do, and then when you passed A into a function, it would copy all of those bytes as it was going into the string. So if I take a string and I just want to print it out, and so after we call make jack, we do something with string. Whatever this variable A gets set to, it is then copied into this function to be printed out. Great if it's short. What if A was some kind of data structure that had several kilobytes worth of data in it? Then all those kilobytes of data have to get copied into a brand new variable each time we call that function. But if we make it a reference, oh, that's not how you do it in that language. You do it like this. If we make it a reference, we're not passing in a copy anymore. Well, why'd that break that? It just doesn't know. Save it, the error go away. All right. By making it a reference, we're not passing in a copy of A, we're passing in the original variable. So it's not like I'm giving you a list and you have to copy the list before you go shop for groceries. You have my original list. You can go off and go off and start doing your business faster. So passing by reference is faster than passing by copy if the data is more than a couple of bytes long. But then we run the risk that it could change it, right? This could conceivably change the value of that string. If I was a bad programmer and I did that, then that now replaces the value of A. So A is no longer what I expected it to be. But I can fix that too. I could say, yeah, I'm passing in this string as a reference for efficiency purposes, for speed purposes. But this function doesn't change it. So don't worry, it's safe to call me. And sure enough, since I marked it as a constant, the compiler is now flagging this as an error because I'm trying to change the value of something that is marked as a constant. You can't change it. It's supposed to be a constant. It's supposed to forbid changes to it. So now the code runs more quickly by passing it in as a reference. So pass by reference lets the function change the value of the argument passed in unless you mark it as a const reference. Why would you do that? For speed purposes. Passing by reference is faster than passing by copy. If the variable size is more than a few bytes. So that's an example of that. We passed in this string by reference so it would work as fast as possible. And again, with strings like Jack and John and stuff like that, then the performance enhancement would be negligible. But if it was a long string, if we opened a file and then read in 10,000 bytes and stored it into that string, and then we called this function and it had to do something with it, it'd be much better to pass it in by reference so that it was actually getting that original data rather than making another copy of that 10,000 bytes before starting to do something to it. So are we thoroughly tired of this topic? Is that making sense?
No. Yeah, it is. It's a little bit confusing to me, but I'm getting there. I get it.
Yeah, it is confusing, and throwing the pointers in is going to make it more confusing still. So I'm not going to talk about the pointers anymore in this lecture. We're going to get back to pointers when we start talking about creating objects. But I wanted to mention them now because they are another way of solving the problem of how do you get a function that can change the values of the things that are passed to it. References are the ideal way, but pointers are another.
Well, and if you don't mind, is there an example of a real world? Why would I do that? Let's say, for instance, I'm an engineer, so I take in orders for projects for different businesses. If, let's say, the customer had some issues at their site and we had to change the date, the due date, would that be a reason why you would do this, or why would you do it?
Well, you do it if you have a function that needs to manipulate data in a more complex fashion than just calculating and returning a result. So you might have some function that needs to open a file and return several pieces of data from that file, not just one. And I'm trying to think of an example, but that's why I had this one return a first and a last name. We could not just do return first last. If we wanted to return two separate variables, we needed to pass them in like that. So if you have some kind of calculation that's calculating more than one return value and you need to pass them all back out, then that is a way to do that. And
Okay.
so any data type that you pass in, if it's something that needs to be changed by the function, you would define it as a reference. So Trying to think. Like you had, I'm not going to actually write the function, but say we had something called process file, and it took a file name as its parameter. And what I wanted it to calculate was to open up the file and return the number of items in the file, and then their average, and their total, and their average. Yeah, that's it. We wanted to open up something and return the number of items in it and the total of those items and the average of those items. Now, those are three values that we'd need to return, but a return could only do one, right? I could return num items, or I could return the total, or I could return the average. I can't return all three of those. So I could pass those in as reference parameters. The number of items, the total of those items, and then the average of those items, which would probably not be an int, right? It'd be a double because it might be fractional. As a matter of fact, maybe the total would be fractional too. And so then this code could open the file, calculate the total, calculate the average. In doing so, it has calculated the number of items, and then return true if it succeeded at all that, otherwise return false. So I'm obviously not going to write the code that would actually do that, but let's say, so after a while, the total, the num items became 7, the total became 90, the average became, total divided by the num items. And it's all good, so let's return true. So it's that kind of thing. We are passing back multiple pieces of data rather than just one return, because a function is designed to do something and then return one value, either return one value or no values. Now, there are certainly other ways of solving the problem. You could pass back data in some other format than just as three variables. You might want to create some data structure that has both a number of items and a total and an average and something like that. But that is one way to solve that kind of problem. This thing needs to perform several calculations and pass back several different pieces of data. Well, pass them in as references so it can do so.
So what you just did there, the return true is our return. That's what sets up the function or makes it complete itself, is returning true if it worked. But we did actually change num items, total, and average.
Yeah, and so if the file could not be opened, for example, we might have returned false. Otherwise, we go on and we do the rest of this stuff.
But that did allow us to change those three variables.
Right, because they are marked as reference variables. So the calling code could actually call process file and get some good data back.
Okay, that makes sense.
So down in main, num, total, average. We have to declare those variables before we can pass them in. So int num items equals 0. And then double total, comma, average. And if our return value is good, if things really are okay, then we could do something with that information.
Okay, and if this gets us too far off topic, let me know. But
Oh, that's fine.
if we wanted to use that function and we were gonna look at multiple different files and do the exact same thing, would we be all right to just continue to use that one function?
Absolutely. That's why we write functions, is so that we can write something that'll handle one case and then repeat that set of operations on other sets of data, other
But it's
files or whatever.
so okay. So I think that's where I'm getting hung up. So we're pointing to an address, changing the variable name. But if we open another file,
Well, that would erase these values. You'd have to do them one at a time, right? You could
okay,
process one file and then you could process another one and then you could process another one. And each time you get new values for these variables that you could play with.
okay, okay.
Guess I'll run it just to make sure it compiles. Code's getting so convoluted that if people don't watch the lecture, none of it's going to make any sense, but that's okay. They need to watch the lecture. So yeah, the number of items 790 and the average was 12.5. It was able to do that. And then if we needed to follow that up to a call to a different file, we could, right? We could process a different file and then handle those results as well. Like file 2, right? And then do something with those results.
Okay.
All right, let's see what's next. That's certainly not next. That's Java. So why do you use reference variables? It provides a way for the function to so-called return more than one value. And how does it work? The function gets the original argument, not a copy of the argument. It refers to the original argument. So it allows it to modify the values in the calling argument. The variables that were passed in can be changed. So a reference variable is an alias for another variable and is defined with the ampersand. Changes to a reference variable are made, or they cause the variable that it refers to get changed. And so that's called passing by reference. So here we have a function called double num, which is going to take a reference. And again, they neglected to give us a variable name here, but that's because they wrote on the next slide, the double num function is going to take a reference to variable so it can multiply that variable by 2 and return it. So each time double num is called, it's going to increase that value by 2, or multiply it by 2. So each time we call, x is equal to x times 2, or they just did x times equals 2. So if I define a number and I set it equal to 1, and then I call double my num, and I do that, several times in a row, then it's going to be 2, and then it's going to be 4, and then it's going to be 8, and then it's going to be 16, and it's going to be 32, and so on. And as always, there is more than one way of doing this kind of thing. We could have just written a function that looked like this, and it would return 2 times x, right? And then when we felt like, what? Oh, one of those phantom ones. Okay, so if we had my num and we felt like it, we could say mynum equals double me of mynum, right? That's totally fair to do. And that probably clicks better in your brain as a way that you would want to do it. And I would agree. I wouldn't start using references and stuff like that unless there was a really compelling need to, right? If you really do need to pass back more than one changed value, that's about the time you start thinking of using references. Or if you're going to be shuffling around large pieces of data that you don't want, you know, those multiple bytes to be copied as it's going into the function and as they're coming back out. What do you think? I mean, if you were just going to write something that would double the very value of the number you were looking at, would you rather do it like that or would you rather do it like that? There's no wrong answer.
Yeah, yeah.
My hunch is that that's the way that I would probably leap to it. If I had to write that in 10 seconds without thinking about it much, I'll write a function that takes a number, doubles it, and returns it. And okay, now I can call it against myself like that. So reference variable notes, you use the ampersand to mark that it's a reference. Spaces aren't important when it comes to that. I could put a space there. I could take that space out. I could take that space out. I could put two spaces there. Right. It doesn't matter. Use when appropriate. Don't use when the function should not, when the argument should not be changed, or if the argument needs to return only one value. Well, I don't mind using it when it should not be changed. I just stick the word const there. So the other time is when it's appropriate is if you make it a const reference because you want to pass in a large data type. And once it is declared as a reference, you can't not pass it in. You know, you can't pass in an expression. You actually have to pass in a variable that matches that type. In here, I can't call double me and do this, right? Double me 100. And hope that it's going to magically take that 100 and change it to 100, 200, right? Because that's a constant. It's a series of, it's not a variable. So this can't be a reference to that. I think I named these things too close together. I don't like the fact that they're different only by whether they have an underscore or not. So I'm going to change that one to call to double me too. Just so I don't have two functions with exactly identical names except one has an underscore. Overloading functions. That was what the last lecture was about. Overloading functions is when you have one function name and multiple versions of it. So we could write a function called say, or greetings. And what does greetings do? It just says hello. But then we can write another version of greetings that takes a first name and when we call it, we print out hello, comma, quote, less than, first name. Maybe followed by the exclamation mark. Why'd we get less friendly just because we knew their name? That's not fair. And then we could write another version of it that took a first and a last name. So first name followed by a space, followed by the last name. Where'd the rest of it go? All right, fine. Followed by an exclamation mark. Session. And then we can call that function either way. This function has been overloaded so that it has three different variants. So we could say greetings, in which case it'll just print hello. Or we could say greetings, Paul. not pale, Paul. Or we could call greetings, Paul McCartney. Wait, Paul, comma, McCartney. And all three of those will work. The same function is working differently based on what kind of functions you're passing it. Now, I forgot to add a second parameter here. So it's giving me a syntax error when I try to pass in two arguments, but that's easy to fix. All right, and so now it'll work. It's going to print, it's going to use all three functions now. There we go. So we have three different versions of it. And so the last lecture went heavy on overloading, so I don't think that I need to talk much more about that unless you have any questions. Is that making sense? The fact that you can write a function that has the same name but different numbers of parameters so that you can create functions that perform the same task on different sets of data, like on one integer or on two integers or on two doubles or something like that.
So I do have one question on the blank one, the one you didn't put any parameters to it. If you could pass an integer or string or anything into that one?
Well, no, I would have to write it in order to accept that.
Okay.
Right? Because although we've overloaded it several different ways, we never wrote one that would take a, well, you said a blank or a string. Did you say anything else other than blanks?
Well, like say the void greetings with no parameter up there, the first one. If you just did, oh, I see. Okay, so that greetings with nothing it's not gonna print anything. It's gonna print hello. That's it.
Right. Exactly.
Okay. So if we wanted to deal with an integer, we would have to build an integer greetings in there.
Right.
Greetings int.
So we could write one that would take an int there. And see out. Let's say hello to the number like that. So then we could pass a number in just as easily as one of these strings. And so when we do, that one, since we're passing in an int, would get linked to that one and print that out.
So you could do that with any type? I mean, you could basically?
Right. Any function you write, if you want to write another version of that function that takes a different data type, that's fine. Absolutely. So in the last lecture we did, lecture Q.
I did watch that. So just so you know, I didn't skip it. I watched it.
Oh, yeah. But I know the way that it worked out is I didn't post any lectures for a week, and then three of them fell in people's laps.
Yep.
So we had one version of add that took two numbers, and then we had another version of add that took three ints, and then we had another version of add that took two doubles. And so we provided a lot of flexibility in how it could be invoked. Now you could do flexibility via overloading, and you can also do flexibility via that other example we had where we're giving optional parameter values. You just have to pick which one kind of makes sense to you.
Well, I was trying to think if you could mix them, if there was any way, like say for instance, an address, if you had just the street numbers and then the street name, could you do an int and a string in one?
What you probably would wind up doing in addresses with street numbers and things like that are usually both handled as string data.
Okay.
Right. Because even if it's, I live on 11th Street, I usually call it 11th with a TH. But like, if you're saying like it's a street address, like 739 East Main in that first one, you'd probably still treat that 739 as a string. But right, you can write the same function so that it'll accept different kinds of data and then manipulate it differently based on the number of arguments that are passed on it to try to make it look like it's doing the same thing. Here we were able to add them in different ways, right? Passing in different kinds of data, and it worked just fine. We didn't have to give much thought into it. before the idea of overloading, you had to do things like this. And I don't know why I'm modifying the notes for yesterday, but anyways, you could write a function called add two that would take two things and add them. And then you could write a function called add three, which would take, come on, and add those things together. But that would require you to, use different function names for every one of these functions. If you wanted to write an add four and an add four, add five, and so on, you could do that. Instead, when they added overloading to the language, it just means that you could use the same name, and then it's up to the compiler to figure out, which version of the function to call based on the number of arguments you want to give it.
Okay, that makes sense.
So the compiler will determine which version of the function to call by its argument and the parameter lists. So get dimensions, taking one parameter or two parameters, or an int or a double, and a double and a double. The compiler will use them as follows. We have two ints, length, width, and we have two doubles, base and height. So if we call get dimensions length, length is an int, so it's going to come up here and call that version. Length comma width, well, length and width are both ints, and so it's going to find the closest match, which is that one. So it's going to run that version of it. Length and height, well, length is an int, and height is a double, so it's going to come in here and find the closest match, which is that one. And then height and base are both doubles, so the compiler is going to hook this call up to execute this version of the function.
That brought it home for me right there.
Good deal, good deal. Yeah, I love that page. I actually had forgotten that page is there, and that's beautiful. That illustrates it perfectly. And the exit function. The exit function just kills the program. Just flat out kills it on purpose. Terminates the program. And so you don't want that, right? But if you did, like if you program reached some error state from which it could not possibly recover, then you could throw an exit statement into that function. So I don't even know. I don't even see a reason to throw one in. But if you want to use the exit statement, you have to include this header file, cstdlib, and then you call exit and you pass a number into it. I mean, I guess I can flip back over to the other project and put some code in there that does that. There we go, like that. Hey, I thought exit was defined in the C standard lib. Is that error going to go away as soon as I compile? Yes, dadgummit. Okay. So anyways, and then say if problem one occurs, then we exit that way, right? So come back. But later on, maybe some other kind of problem occurs. A different kind of problem occurs. You could think of this number here as being an error code. And so you could exit returning an error code. And what does that do? That means that the operating system can check the results of the program and check to see what that error code was. Effectively, that's just the same thing as returning something from main. If you're down here in main, way down here in main, way down here in main, main was defined as an int. And for some reason, the compilers are lazy enough to not call it an error, that it didn't return anything. But without that return statement, what it's really doing is returning a 0. So I think on our boilerplate that I was using up until I installed this version, I always had system pause there and then return 0. So generally, 0 means all is well. Everything worked great. There's no errors in it. But if you return a non-zero value and you wrote this to be invoked from a script file, some other thing that called this program, and you could check its return code, then you could see what the program returned. And if it was non-zero, then you would know that it was some kind of error state. And you could, you know, through some automated process, you know, send a text message, you know, alert the administrator that something happened, or you could look at the results or whatever and find out that it works. So exit just kills the program and returns a value to the operating system. That's all it does. So if I stick a call to oh no somewhere here, then it's going to kill the program there, and I'm not going to get to see the rest of the contents. Looks like I didn't open it as a project, but just as a file. Is that true? It's not letting me make any change, letting me run it. Oh, well, I don't care. Talking about it was enough. So the exit function just kills the program immediately, and it sets a code that can be checked if the code has been called from another program. Because you can write a program that calls another program, and that program can call another program, and you can be checking the return values from them. So example. And so the C standard lib defines two constants that are already two common variants of it: exit success and exit failure. But you could have success is probably just 0. That's my guess. I think if I go and I try to use that value, and I do, what is this? Oh, it's still running. Is that why I didn't want to compile and run for me again? Yeah, okay. So way up here, I bet if I click on that, right click and do go to definition, it's just 0. A 0 is counted as success. And then you could have any number of non-zero error codes. And they made a generic one just called failure. And guess what? My voice is completely given out. So this is a good place to stop. We only have one more page anyways. All righty. So I think we have homework for this week that we've already assigned. So do I need to come up with anything else over the concepts that we've talked about? Let's go take a look at what our current, what is that? Oh. Nah. I think if we do homework 9, we're going to be good to go. And so we'll assign more for next week.
And I just noticed that I do not have my chapter 5 quiz done. I just saw that, so I'll get that submitted.
Oh, okay. Okay, that'd be cool. All righty. So I appreciate you being here. It's much better to lecture when I have somebody to talk to.